So, here's my jury rig setup for charging my battery. I apologise for the noise. That is this very cheap membrane pump that I definitely will be using in the final product. But that is just circulating water through the charger. This on the left is battery emulator, which is running on this LilyGo CAN bus thing. That is talking to the battery BMS, which has no control at the moment. It is purely just a data reading service which gives me both state of charge and state of health and the ingoing power, and monitors all the battery voltages in one go. Nice and easy. I can use the original BMS, don't need to reconfigure any wires, and whilst it's in the battery I can just use the original housing. On the right here is the serial connection into this Brusa charger. That has a profile which is set using ChargeStar. Top tip, that can run on Windows 10 so long as it is Windows 10 32-bit. So this is now a 32-bit installation of Windows 10, which can run most of the programs you need, like PuTTY and browsers. Not going to be your most fun experience with limited RAM, but it runs. And the benefit is you can install it from USB, and a lot of device drivers just work, like this USB serial port adapter, which is what's connected into the charger there. Keeping the charger cool is this big old bucket of water, which is currently at 25.7 degrees. Supposedly the charger will derate at 60 degrees incoming water temperature. I don't know how that relates to the power stage temperature. It might be that that can get quite a bit higher. This is getting fairly warm. I don't know whether it derates when this gets to 60 degrees or not. I'm at the flow rate specified by this charger, so I'm assuming it's probably got a water temperature sensor and it's using that. Right now I've got it limited to 13 amps, which you can see just shy of 3 kilowatts there, using that potentiometer there, which also sets the the amperage limit there. So the charger is calling for 16 amps, but it's being software limited to 13 amps, so that based on that potentiometer, so I can manually limit it if I want to plug it into a 7 kilowatt or a 3 kilowatt. It's going to do 3.6. But I can plug it into a 7 kilowatt and draw the full 3.6 kilowatts and put 3.3 in the battery without exceeding, but whilst also not exceeding my local usage, and without having to deal with any of the intercommunication of the Type 2 standard. This is just wired up to the LilyCan and the charger. Just bring it back out again. The contactors are handled with these DuPont connectors. They are powered by this little variable power supply set to 13.5 volts. That also powers the LilyGo, so I turn that on. Powers up the LilyGo. I can connect a battery emulator then, and check that everything's good. Then I plug in the purple wire to the orange terminal. That is the pre-charge resistor. That just prevents me from blowing up the charger. Leave that for a few seconds, then I plug in the white terminal, and that's the main contactor, then with DC live. Then that runs over the two wires, currently not earthed to the battery. I guess it's touching the metalwork, but there's no solid earth. That then runs via this cable that came with the charger into the charger, which is can put out up to 3.3 kilowatts into the battery, 3.6 kilowatts drawn. Then this has a multi-pin connector, which I've labelled the pins of. The only real important ones are the power on and aux, which are there, which are set to run the charger in auto mode. So whenever you plug in the AC, the aux cable, which is this short one here, goes plus 14 volts. That then sets to the by connecting that to the power on, which turns the charger on when it receives that voltage. It just automatically starts charging when you plug it in. So that's nice and easy. You don't need to worry about turning anything on. You just give it voltage and it's like, oh, okay, I'm off, I'm charging. My plan is to integrate this charger fully within the battery. So once I've installed it, it will just be permanently hooked up to DC. So I don't need to worry about not starting the charger before the contactors turn on, but I could also wire up the power on the contactors as well if I wanted to do that. That would be an option as well if I wanted the charger externally. This supposedly requires 4 to 6 litres of water of cooling, which is what I've got running off this pump, which does pretty much exactly that. Only draws about 24 watts in this kind of unloaded fashion here, where it's just kind of trickling out, but it appears to be keeping it cool. The water temperature up to 26 degrees now. Not got a radiator in this loop, and just relying on the thermal mass of this water to keep everything cool for the duration of this. It's a very small battery. It's only 22 kilowatts hours, and it's 68% state of health, so it's only 18 kilowatt hours total capacity, and I'm only charging it up halfway. What I'm doing right now is babysitting the battery, making sure none of the voltages go out of whack. We've got a cell data of 10 millivolt there, so we're very, very tight on our batteries. Battery cells, I think that's the minimum it can report. I want to get this above 93%. Supposedly that's the voltage at which the BMS on board will start balance charging. So I can leave the BMS turned on, the contactors closed, and let it kind of balance itself out a bit. I've set the charging profile to charge to 375 volts at a constant current of 16 amps. Once it reaches 375 volts, it will hold at 375 volts. And let the current drop until it reaches 1 amp. Once it reaches 1 amp, we'll switch to the next phase, where it will charge at a constant 10 amps until we reach 390 volts, which is my playing itself. I'm pretty sure this battery goes to 401 or so volts, but I want to keep an eye on the state of charge here, make sure we don't get too close to 100%. Just in case the 100% as reported by the BMS is lower than target. But yeah, once this reaches 375, it will switch over, it will kind of slow down until it reaches 1 amp. That's kind of just a balancing step. With these lithium batteries, it shouldn't take very long. It's designed kind of for balance charging lead acids, let them soak in before you start trying to push them higher. But it's a nice easy check to just make sure nothing's out of the ordinary, let everything normalise, then push it up a little higher to get that top rate. Not looking for fast charging from this thing, that's why it's a 3 kilowatt charger, you know. But no, this is working pretty well. No real issues. It just starts right up. No data communication. Running. It's pulling a steady 3 kilowatts, pumping it into this battery. And yeah, next step on this is going to be to look at getting a motor driver set up so that I can start driving my motor, which came from that piece of metal up there. That's the gearbox. That's just one half of the gearbox and an AC compressor. And the idea is that once I got this battery up to a good voltage and I can check the charger behaves itself, then the only thing I need the battery to be in this config for is motor drivers. Once I can make the motor driver spin the motor, then I'm good to go on disassembling the battery and packing it into my donor car, which is over there under a black cover. It's an MGB GT, of which I think current plans are 8 of the batteries in the boot, 4 on the boot floor, 4 under the boot floor, and then the remaining 4 battery modules will be up in the front along with the charger, contactors, all that jazz up front. But yeah, this is going real well actually. I've just got to babysit this thing as it very slowly charges, now up to 48%, as it very slowly charges up to full, so I can make sure that the charger reacts correctly as it charges.